In the previous video regarding limits, we have solved limits using substitution method. You can find that video in the playlist differential calculus. When we can't use substitution to evaluate a limit because plugging in the value we are approaching gives an undefined value, factoring is the next approach we should try. We usually use factoring when we are finding the limit of a rational function, such as this one, where our goal will be to factor both the numerator and denominator as completely as possible and then cancel any common factors. Our hope is that once we have cancelled common factors, we'll be left with a function that can then be evaluated using substitution. Using substitution to evaluate the limit means we will plug x equals to 4 into the function. For example, if we plug in x equals to 4 here, x equals to 4, we shall have 4 squared minus 16 over 4 minus 4. So in the numerator we'll get 16 minus 16 because 4 squared is 16. So in the numerator we get 0, denominator also gives us 0. This is 4 minus 4. Sorry about that. So the result is undefined result. So we should try factoring instead of using substitution. There's no factoring to be done in the denominator as it's completely factorized. It is in the lowest term possible, but the numerator can be factored as the difference of two squares. If you look at the numerator, which is the same as x squared minus 16, this can be factored as x minus 4 multiplied by x plus 4. This is called a difference of two squares from the quadratic a plus b, a minus b, which gives us a squared minus b squared. That's from the quadratic factors, a difference of two squares. Now we can substitute x squared minus 16 and replace with this value. We shall have limit, LIM stands for limit, as x approaches 4, x minus 4, x plus 4 divided by x minus 4. Once the numerator is factored, as you can see, there is a common factor of x minus 4 in both the numerator and denominator. And therefore, we can cancel that. If we cancel that, we remain with the limit as x approaches 4, x plus 4 only. So we can, now that the function has been factored and simplified, we will try substitution with the simplified function. Now substituting x equals to 4 into the function gives 4 plus 4, which is supposed to be 8. Therefore, the limit of the function as x approaches 4 is clearly 8. So the value of this limit is 8.